The variable should be in front.
Well, yeah, you have here what? We have here an assignment. Okay, so this equality here is assignment operator. Now, what is on the right hand of an assignment? Assignment is operator like any other operator. So there is rule, what can be on the right hand side and what can be on the left hand side. Okay.
Left hand side is the variable, right hand side is the value assigned to it.
Yeah, on the left hand side must be a variable. Okay, on the right hand side should be an expression. Now, x is an expression, so that's perfectly okay. However, here, this is also an expression. 2 is not a variable. It is a constant. Constant is an expression. So we are violating a rule that on the left-hand side must be an expression, a variable, and on the right-hand side should be an expression. And therefore, it is syntactically incorrect. Now, the second example, this one here, you have an expression on the left-hand side, and you a variable on the left-hand side, sorry, and an expression on the right-hand side. So that is okay. However, this symbol here, colon equals, is used for assignment in Pascal or in Algo, but not in C. So if we have C or C++ or Java or any of these languages that is having different symbol for assignment, then this is just a wrong operator, and therefore it is a syntax error. Then this one here, what's wrong here? Well, what's wrong here is rather simple. What is wrong is this question mark here. Why question mark? Well, somebody was writing an if statement, and it was if a is greater than 3, then put x is 1, otherwise put x is 0. However, if you take your keyboard, you will see that question mark is next to greater than. So by pressing the wrong key, you can easily put here question mark. And of course, question mark is part of ternary operator. And here we don't have ternary operator, and we have just 2 values. So this is syntax error. This is something that compiler cannot process. Then we have here cout alpha, cout beta. Okay, what is wrong here? Well, this is a simple one. What is wrong? If this is C++, for example.
The cout should be, there should be a semicolon between the 2 cout statements.
I cannot hear you very well, unfortunately.
There should be a semicolon between the 2 cout statements.
Bravo, bravo, bravo. There should be a semicolon. Why semicolon? Because semicolon is C++, and in C is terminator of a statement. So each statement has to be terminated with semicolon. There are languages that use semicolon as separator to separate 2 things, but C++ uses that as terminator. Therefore, you cannot have here missing semicolon. How about this C in ABC? Well, this is what happens when an old Fortran programmer starts studying C++. And then in Fortran, you say read A, B, C. And then you can read these 3 values. And then if you ask C++ people how to make read, they say, there is input stream, and you put inside. So Fortran programmer will say, input stream, put in input stream A, B, C. Well, you cannot do that. You cannot extract from input stream in this way. Therefore, it is a syntax error. So syntax is formal correctness, not about meaning. Meaning is discussed in the area of semantics. Semantics is analysis of meaning of language constructs. So what is the meaning? How the compiler interprets language constructs, statements, and everything else. So that is what has to be studied now. So again, to understand what is meaning of language constructs from the standpoint of language processor, let us see a couple of semantic errors. For example, this one here, alpha equals 1.7 times ABC. So what is wrong here? Can somebody say what is wrong?
You can't multiply a float into a string.
Excellent. We have here what? We have here multiplication. So multiplication is an operator that is defined by saying on the left-hand side, you have arithmetic expression. On the right-hand side, you have arithmetic expression. You evaluate this arithmetic expression, you multiply these two values and return whatever is the result. Okay. However, you cannot multiply the real number, 1.7, and the string. So this has no meaning, and the compiler cannot create this, cannot translate this and create machine language for this expression. How about the first one? This one is tricky.
So
is this okay or not?
Output, one is arrow, which is a string, and square x, which is a number. So the output does not match.
Again, I cannot hear you. Let me try for a second, if you permit me to try. I have here some earbuds that are better than this. All these new computers are very slim, and in order to make them light, they put speakers at the bottom. And you put speakers at the bottom, you can hear nothing from them. So let me try to put these earbuds. And would you be kind to repeat what you said?
So for this ternary, x is less than 0 point is fine because it's correct. But the output, the string error is a string, and the squared x is a number. So the output does not match.
Okay, this is very, very close to the correct result. Very good. And another thing is that I can perfectly hear you from with these earbuds, and I couldn't hear you from the speaker of this new machine. So what I learned that I have to have these earbuds, because then I can hear you. You still can hear me okay with this microphone that I have. That's the basic thing that I want to know. Do you hear me okay or not?
Yep.
Yes, we can hear you.
Yes.
It is okay. Good. Because this is the machine that I use for the first time. They just gave me this machine. So it is nice, has big screen and blah, blah, blah. But on the other hand, the speakers are miserable. So I have to have something in my ears. Okay. Now, semantic error here, what we started to discuss. Here is an expression. You see this expression? Expression starts with this parenthesis here and terminates with this parenthesis here. So if I have an expression, then what can be done? The idea here is that the programmers say, if x is negative, then I cannot compute square root. Therefore, if x is negative, I want to print error, which is a string, of course. This is ternary operators. You have question mark and colon. So this here is true or false. So if it is true, then you are going to return this error. Otherwise, you're going to return this square root of x. So what is square root of x? By definition, square root is taking double precision argument and returning double precision result. That's what happens with square root. So this guy here is double precision. This here is a string. So depending on this x, you can return either string or double precision real number. Okay, if you have dynamically typed language as Ruby, this is perfectly okay. But this here is inserting this expression in cout. So this here is C++. And in C++, this is an expression. So since this is an expression, I can decide to multiply this by 3.14. So I can put here 3.14 times this parenthesis. Now, what is going to happen? What's going to happen is that if this 3.14 is multiplying this double precision number, that's fine, that's okay. However, if 3.14 is multiplying string, it is going to be the same tragedy as here. So obviously, data type of this expression and data type of this expression must be the same. So this should be double precision and this should be double precision, or this should be string and this should be string. So they have to be compatible. Whatever comes from this parenthesis, this pair of parentheses must be a single data type. And that's not the case here. So this is semantic error, and compiler cannot translate this because it has to be able to return a value that has a single data type that can then be used in any way you want. But here is heterogeneous and incompatible data type. You can have here integer expression, here double precision. That would be okay still, because compiler will say, aha, I have to convert this from integer to double precision. This is double precision. We'll insert one function that is converting from integer to double precision, and everything will be okay. Would simply return double precision, and then you can multiply this by 314 if you want, or whatever else. So obviously, this is in the case of statically typed languages, this is a mistake, semantic mistake. On the other hand, is this syntactically correct? It is perfectly correct. Left parenthesis, right parenthesis, correct. Left, right, here. Function written in correct way. Question mark and colon, perfectly okay. Here, x less than double precision 0, perfectly okay. String, perfectly okay. So syntactically, everything is fine. This insert operator, insert in output stream, perfectly okay. So syntactically completely clean, semantically completely wrong. And here is also syntactically clean, semantically wrong. Here is a jump statement. Go to label 20. That's perfectly okay. The simplest possible go-to statement. So you want to jump from here to label that is labeled 20. But how about the case if label does not exist in program? So if you have to jump to 22 and you put 20, so compiler cannot jump to non-existent destination. Therefore, must stop here and say, hey man, you have a semantic error, so correct this, I cannot do that. Same is with this n equals 1. Well, that's perfectly simple statement. You assign to integer variable and the value 1. But if you don't define variable as an integer, you have undefined variable. Undefined variable is a semantic error, so it has no meaning whatsoever. So this is something that we have to correct. Then you have cin, insert x. This is again insert operator. Insert operator is operator that is defined. What is on the right-hand side? On the right-hand side is an expression, an arbitrary expression. Very good. What is on the left-hand side? Must be an output stream. Output stream. What is this guy cin? Cin is an input stream. So you try to insert an expression in an input stream. This is, of course, semantic error again. So as you see, these are typical semantic errors. So all of them are syntactically okay, but have no meaning for compiler. Compiler cannot find any meaning in this and create machine code that will execute this. So these are all semantic errors. So we differentiate syntax as formal correctness of language constructs and semantics, which is meaning of language constructs. Now, we have another concept that is important, and this is language that is used for this describing the syntax of other languages. So object language is language whose syntax is analyzed. So we are now focused on syntax, not on semantics. So how to define correct syntax? Well, you have a specific language that you want to describe, and you have language that is used for describing that object language. So object language is language whose syntax is analyzed. And then meta language is language that is used for describing object language. For example, you want to take at SFSU a class of any foreign language, for example, English or Russian, of course. And if you take the class of Russian, a professor is going to teach in English. So English is going to be meta language for Russian, and then you take this class. Or you can also go to Russia and study English, and then English is going to be an object language, and Russian will be a meta language. So the question is, what are meta languages for describing programming language? What are notations that are used for describing syntax of programming languages? There are 4 of them. BNF, or Backus-Normal form, or Backus-Naur form. There is also eBNF, extended BNF, and there are also syntax diagrams. And after that, parenthetic notation. There are 4 of them. So we are going to start with BNF. This is going to be the first one. Before that, let me just make one short break to remind you that in programming languages and elsewhere, we have various forms of equality. So equality, this slide is not in the reader. I usually write that on the whiteboard, but here I put another slide. So equality is used for 2 things, for assignment or for relational operator. So what we have here, we have assignment, variable equals expression. So evaluate the expression, return a specific value, and insert that value in this variable. And then if it is C++ or some similar language, then this is going to return a value that is equal to this expression, and nobody will use that. That's perfectly okay. So this is assignment, variable equals expression. But we also have relational operator. So we have expression 1 equal expression 2. So what is done in this case? This expression 1 will be evaluated and some value will be generated. Then expression 2 will be evaluated and some value will be generated. And then we have that expression 1 is tested for equality to expression 2. So this can be either true or can be false. If it is true, then you return the logic value true, that these expressions are the same. What compiler is doing, evaluating this, and then subtracting these 2 values. And if subtraction gives you 0, then it returns true, otherwise it returns false. So assignment and relational operator. Syntactically speaking, what are people using for this assignment and this relational operator here? Well, there is gazillion of different symbols that are used. And I want just to remind you what is used in mathematics. If you take mathematics class, they say you have equal by definition. So what is equal by definition? Well, there are 3 symbols that are used. You either write equality and put def on top of that. So this is like we are now defining some new object that we are going to use in some analysis. Mathematician also put this little delta on top of equality sign because this is also used as equal by definition. However, by far the best of all of them is this colon equals because it is both simple and you have it on each and every keyboard for equal by definition. And another thing, it is not symmetrical like this here. So it has left-hand side, right-hand side that are different. So on the left-hand side, you have what is being defined, and on the right-hand side, you have the expression that is given, that is defined. So this is assignment, that means equal by definition. Relational operator is just simple equality. So you can say A equals B, and that means that they are the same. Okay. Now, this is used also in various programming languages. Now, programming languages, each language has different rules how to do that. For example, the old grandpa Fortran is using assignment as equality sign. Well, this is fine. This is what everybody uses today. For example, you have that in Java and in Ruby and C and C++. But for relational operator, they were using EQ, equal to. So Fortran is case insensitive language. So you can write that in lowercase and in uppercase. So for greater than, they use GT. For less than, LT. For equal to, EQ. For not equal Q, not, NE. And when you use that, then you have that this EQ would be practically interpreted as a variable. And therefore, you must do something to prevent this to be interpreted as variable. And how to prevent that? Well, you have to put dot before and dot after it. And that's how these dots came into operation. So the compiler knows that this is not a variable, but it is equal to relational operator. And this was up to 1977. A standard that was introduced in 1977 was always having this as assignment, this as a relational operator. And then it came in 1990, Fortran 90, and they said, we've seen that in C, it is better to have this two equality signs. So they said, we are going to steal that from C and bye-bye with EQ. So now, from 1990 to 2015, you have that this is assignment, this is relational operator. In Java, Ruby, C++, C, this was from day one, it is still that way. This is assignment, this is relational operator. Then Algol and Pascal, they are languages that introduced equal by definition taken from mathematics. So they say, this is assignment, and this is relational operator. So if you have simple equality sign, this is checking whether an expression is equal to the other expression. And if you have this equal by definition, this is assignment. So if you say A equals B plus C, you are practically having assignment B plus C is computed and the result is inserted in A. However, some languages like BASIC say we are going to use the same symbol for assignment and for relational operator. How is that possible? Well, they say, you know what, a compiler is not stupid. You see from context what you want to do. So we don't need to have two different symbols. We are going to use the same symbol here and here. So if you say if A equals 3, then do something, then compiler understands that this is relational operator. So if A equals 3, this is not assignment. It is part of each statement, and therefore inside is something that must be relational operator. But if I say X equals 3 times A, then this is assignment. This is not relational operator. So they use the same symbol. And then the compiler decides what is that. So this is also possible. So you see, there are various symbols for assignments and various symbols for relational operators. So now we come to meta-language. What to do in meta-language? Well, if you have a language that is explaining another language, for example, you want to learn Russian using English. So in these two languages, they must be different. The basic thing is that meta-language must be different from object language. So you cannot explain one language in a language that has exactly the same word. So you don't know to which word you belong. So in English, you say no, no, and in Russian, you say niet, and that's a different word. Or yes is yes in English, and da in various Slavic languages. So this has to be different. So the first thing that this guy who were creating meta languages like John Backus-Naur and other people, they had to have some equality that is different from all languages. So they were looking at this one here and say, hey, we have to make something different. And this something different, they decided to put here another column. So assignment in meta language is colon equals. That is what they decided. And this slide is just here to tell you that if you have all this that is already used in language, you have to invent something different, and something different is this colon equals. So taking that into account, let us start with the first of that. The first meta language is BNF, which is Backus-Naur form. It was used for definition of algol. So who is Backus? Here is Backus. John Backus is the guy who invented Fortran. He was practically the leading developer of Fortran in a group that developed Fortran in 1957. So the first Fortran. And this is John Backus, and there were a couple of more people working with him to define Fortran. And then after Fortran, immediately in 1960, there was algorithmic language, ALGOL. ALGOL stands for algorithmic language. And this is language that was absolutely fantastic. They invented plenty of new things, including recursion. Fortran didn't have recursive functions initially. For 30 years, there were no recursion in Fortran. So they defined recursion, arrays, dynamic arrays, variety of beautiful things. And the guy who was involved in that was Peter Nohr, this guy from Denmark. So this is American, this is a guy from Denmark, and they were in the committee that defined ALGOL. So they made a fantastic language. The only stupid thing that they did is they didn't define input-output operations. They say, you know, when company gives you compiler, it is going to put something for input-output. And I remember from late 60s or beginning 70s using ALGOL, and there was a French compiler developed in Grenoble. And this compiler with ALGOL 60 had only two possibilities. One is to read 8 numbers from punch card and to print 8 numbers on printer and nothing else. Of course, there were no screens at that time. There were punch cards. So you didn't have anything better for read and anything better for write. And then obviously this language was not particularly popular because you cannot make portable software and all this stuff. And mathematically, it was fantastic, but there is no input output done in proper way. And when you go from one machine to another, your input output is not working. You have to change something. So they created the syntax called today Backus-Naur form or Backus normal form. So this is BNF. Now, what we have in BNF, what is different from language? First of all, there are 3 things. Meta symbols. Meta symbol is a symbol that denotes a particular object. So what can be an object? An object can be if statement, or it can be arithmetic expression. So we want to define an object called arithmetic expression, or an object called unsigned integer. So 123 is an unsigned integer, doesn't have sign, minus or plus, but it is just unsigned integer. So the way how to define that is to put these angular brackets left and right, and put here something that has mnemonic value. So if this here is a digit, you have to call it digit. You cannot call it X, because this is for human consumption. This is not for computer. So you want to define to the guy who writes compiler, what kind of object is that? So people have to be able to read this. So you put inside arithmetic expression or if statement or for statement or do statement or whatever you want to define in the language, but must be readable for humans. And to say that this is an object in meta language, you put here these angular brackets. Is this clear, or there is any question about this? Here we have digit, here you have letter. So when you put here letter, that means any letter, A, B, C, D, etc. So in order to say the digit can be 0 or 1 or 2 or 3, you need or, okay? So what is OR? OR is this vertical line. The vertical line is exclusive OR. So you can say digit or letter. So you can say character is digit or letter. Forget special characters for the minute. So if you have digit or letter, you need to have OR. So this OR is this vertical line here. Vertical line is this OR, and this is the second component of Backus-Naur notation. And finally, you have to define objects. So you have to have assignment. And this symbol here is used as a relational operator in many languages. So you cannot use it. This here is used in mathematics and in Pascal and in Algol. Pascal uses this as an assignment. So you cannot describe Pascal with that. Therefore, you have to have something different, and this different is this colon equals. So to summarize, BNF has three components: meta symbol, which is defined, developed to define an object that has specific mnemonic name. This is this X, exclusive OR and assignment of the value. So how this works? Well, here is an example. We want to define digit. So we want to tell the compiler or the other programmer what is digit, what is acceptable as a digit. So digit can be 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. Now, if you want to be completely correct, you should write here decimal digit, because you can say, hey, we are working in octal system, so digit is from 0 through 7. This 8 and 9 does not exist. Or you can come and say, I'm describing objects that are binary, so digit is only 0 or 1. Or you can come and say, this is hexadecimal digit. So you can say hex digit would be this 0 through 9, but then you are going to have A, B, C, D, E, and F for 10, 11, 12 to 15. So this is assumed to be a decimal number. Okay, so decimal digit is either 0 or 1 or 2 or 3, etc. So what we have here in this first line is object name. So object name is this digit, blood. So this defines object called digit. That can be any of these digits. Then we have equal by definition, so it is defined as, and this is meta expression. So what is inside? It can be 0 or 1 or 2. So this 0 represents itself. So this is token or terminal symbol. So this is something that cannot be decomposed. That is as is, a constant value that is going to be used as written. So this is called terminal symbol or token, and it can be 0 through 9. And then digit is meta symbol or meta variable. This is variable in Metalanguage. So this is expression in a Metalanguage. What we have here, it is defining an object called digit, and this object called digit can be substituted by any of these tokens that we have here, by any terminal symbol. So wherever you have digit, you can put inside 3, and this is going to be correct, and compiler must accept that as correct. So is this definition clear? We define digit as 0 or 1 or 2 or 9. So these are 3 basic components that we use. We have variable, assignment, and exclusive OR. So you can ask, is it enough to have these 3 simple things to explain any language? Yes, it is. That is a good news, okay? You don't need anything more than these 3 basic components. So tokens or terminal symbols are written in any way that is necessary, some of them uppercase, some of them lowercase, but these are symbols that represent themselves. So if you have letter A represents a character A and nothing more. 3 is a digit. So they are written as they appear in a programming language. For example, if you want to define an if statement, so you say, now we are defining an object called if statement. And this is defined in the following way. The first thing that you have is this token if. Can you change this if in some other way to put here IFF? No, it should be written exactly this as if. You have keyword else. Else must be written exactly as else. If you have here else without this E, this is going to be a syntax error. Therefore, this if and this else are terminal symbols. They represent themselves. So you have to write them as they are if the compiler has to understand them. Then, if statement after if must have a condition. And if this is some kind of C, C++ or similar language, you have to put this condition inside parentheses. So after terminal symbol if, you have this pair of parentheses that must be written in this way. What is inside? Any condition. A equals 3 or A greater than 5 or A plus B greater than 3 or whatever condition you put inside. You have to define what is condition. Then after that comes a block. So if you have if condition then block, then this is called skip statement. You either execute this condition or you either have that condition is true and then you execute block, or you simply skip this block and drop to the next statement below that. So that is the first version of if statement without else. But you can have if statement with else. So you say or, so it can be if condition then block, or if condition then block, else another block. So now you have to define what is block and what is condition. But this perfectly defines if statement. So if condition, then execute this block, else execute this block. If condition is true, take the block number 1, otherwise take the block number 2. Okay, now you have to define other things, and here is definition of digit. So digit is 0 or 1 or 9. You will need also sign. So what is sign? Sign can be plus or minus, but can be also omitted, so can be empty. So what is empty? Empty is an object that is legitimate object of specific type, but it doesn't have any content inside, like an empty set. An empty set is still a set. Okay, do you agree with that? It is a set. Empty set is a set, but there is nothing inside. So here we have that in addition to plus or minus, you can also have empty, and this is the situation where the programmer decides not to put plus. So if you say x equals plus 3, that is perfectly okay. But if you say x equals 3, that's the same thing. So you don't need this plus. So you can put that sign can be either this plus, it can be minus, or it can be omitted. If it is omitted, all computers will understand that this is plus, and therefore you don't have to write plus. So now you have what is to say what is empty. Well, empty is defined in this funny way. Empty equals, and you have here nothing. So empty is nothing. It is an empty object. So object that is missing, that is not over there. So empty object. Some languages have empty that is defined as nil, for example, or some specific symbol. Ruby has such an empty object. But empty equals empty, theoretically in BNF, you can write it in this way. So another thing that we have to understand is a sequence. For example, I can define, this is an example. In example, we say, let us define letter to be A or B. So we have letter is either A or B. We don't accept any other letter. And then we have definition of digit. digit is 1 or 2 or 3. So digit can be substituted by 1 or by 2 or by 3. And letter can be substituted by A or B. And now we define another object called variable. Variable is called var here. So variable is defined as letter followed by digit, followed by digit. So if I have here letter and then digit after that and digit after that, then we have that these are three objects that are concatenated, written one after the other. So first comes letter, then digit, then digit. So what is going to be this var? Var can be something that starts with A or B. So here is with starting with A, here is starting with B. Then comes digit. Digit can be 135. So I have A1, A3, and A5, and nothing else. Another digit can again be 135. So I can have A11, A13, A15, A31, 3, 3, 3, 5, 5, 1, 5, 3, 5, 5. So this is everything that can be written that starts with letter A. Now, if it starts with letter B, you send the same thing. So a variable that is defined in this way can be one of these 3 plus 3 plus 3, 9 plus 9, 18 objects, and nothing more. So this definition, syntactic definition, defines variables that have this structure, and neither more nor less. So this is definition of variable that is restricted to A, B, and 1, 2, 3. So it must start with letter. What you have here, that variable must start with letter. So you cannot say 1, 1A. It is not going to be okay because the first component has to be a letter. So must be either A or B and cannot be a digit. Okay, so the first character must be a letter, second character must be a digit, third character must be a digit. So when you have a compiler is tokenizing this, taking this piece by piece, taking first character, and then going to this definition and say, hey, at the beginning, first character must be a letter. Is it a letter? Then it is going to this definition and looking A, B, say, yes, it is. Okay, let's go now to second one, this 5 here. 5 should be a digit. Let us see, is 5 listed in the list of legitimate digits? Yes, it is. Okay, now this one, is this one that is the third component? This is this digit here. So we have to see, is this one? Go to digits, find one here. Yes, it is. Okay, so all this is correct and this A51 is correct. But if I put here A1, 2, then A will be okay, 1 will be okay, but this 2, if I put here, is not among digits, and this will be a syntax error. So this is the sequence of objects. They are written one after the other. Well, now we have things that are more complex. The first thing is recursive definition. What is recursion? Recursion is a method to define an object in programming language. So you define an object of specific complexity that is defined as the same object of lower complexity and something that you do on top of that. So for example, in the case of factorial function that is used always as example of such case, what you have in factorial function, you say f of n equals n times f of n minus 1. So f of n is function of argument n. And you define this function using the same function, f, but of simpler argument of n minus 1. So f of n is defined using f of n minus 1. Okay, so how to define an identifier of an object? So this is identifier or the name of variable. The name of variable can be alpha, can be A15. It must always start with the letter. So this BNF definition here is saying this. We are going to define an identifier of a variable. So identifier can be alpha, for example, or JB007, or A1B2. So these are all correct identifiers. So what you see in all these identifiers, XXXC777, you have that the first character must be a letter. That's it. You cannot put here digit as the first character. So if you put 7 is not identifier of an object. It is in programming language, okay? 7 can be identifier of a file in an operating system. So you can define a file called 7, and this is going to be correct name under Windows. That's perfectly okay. But in a programming language, 7 is a constant, not the name of variable. So alpha is perfectly okay. James Bond, perfectly okay. J is letter. A1, B2, ugly, but correct. X is correct. XX is also correct. So all these things are correct identifiers. So identifier consists of what? Consists of a letter followed by a string of characters. This string of characters can be whatever you want. So this C is followed by this string of 777. It is ugly, it is meaningless for humans, but it is correct from compiler. Compilers say that's fine with me. XX is also good because you can say this is X, and this is, for example, square of X times X. So this is a reasonable way to do that. Okay, so going back to definition, we want to define identifier. Identifier can be a single letter, X, or it can be a previously defined identifier, and then we append the character at the end. So you have to understand this. Identifier is defined as a letter or previously defined identifier and a character that is appended at the end of it. So you can say here in this example, is alpha an identifier? Well, alpha is an identifier because it has here at the beginning a letter, A. And then what you have after that? Another character. This is L. And this is also correct. So after A, we have this LPHA, which is another string of letters. So this is perfectly okay. All this James Bond 007. After J, you have another identifier B007. It is simpler, okay. And then after JB, you have a character that you append. This is 007. So that's perfectly okay, according to this definition. So you have that identifier is a single letter or a previously defined identifier, after which you put a character. So for example, what is previously defined identifier? For example, alpha. And after that, you put character. Character is what? Number 3. So alpha 3 will be correct identifier because alpha is correct identifier, and you expand that by appending a character. So you have identifier alpha 3 equals identifier alpha, and you append character to that. So this recursive definition is defining how we build objects from components. So you can say, I am going to make an identifier by taking either a single letter or taking a previously defined identifier, and then I'm going to append the character. Say, wait a second, you have to tell me what is a character. Yes, of course. Now, when we go deductively from this definition, we now have to say what is character. So what is a character? Character is digit or letter. Okay. So character can be either a digit or a letter. So you can put here identifier alpha, and then after that digit 1. So alpha 1, alpha 2, alpha 3 are good identifiers. Or you can say alpha X, which is also going to be alpha X, alpha Y, alpha Z. Perfect. This is also going to be correct identifier. Now, what is digit? Decimal digit is 0 or 1 or 7 or 8 or 9. Now you have to say, what is a letter? Well, this is a tricky issue because if you say that the letter is A, B, C, D, E, F, G up to X, Y, Z, then this must be lowercase. So only lowercase letters will be permitted if you define letter in this way. If you want letter to be lowercase or uppercase, then you have to put here or capital A or capital B or capital C and so on and so forth. Then comes the question, okay, is underscore a letter? If you want to have underscore as a part of your language, then you have to put here or underscore because this is also a legitimate letter. Then you can say, wait a second, is it possible that the underscore is a variable without anything else? Well, if you go to Prolog, they say, yes, of course. It can be underscore, this is anonymous variable. It has semantic interpretation. Everything is perfect. But no other language will tell you that you name a variable with underscore. You cannot have underscore in other languages as a variable name. But you can use it as a part of language. For example, many languages will use for some internal variables, variables that start with underscore. So system variables will have underscore and then something else after that. So if you have that character is digit or letter, digit must be this one, and letter must be this one. And therefore, you cannot put as a digit hexadecimal digit because digit is defined as a decimal digit here. You can redefine that. You can put here octal up to 7, that's fine. But then 8 and 9 would be illegal. So these definitions are strictly defining what is syntactically correct and what is not. Okay. Now, pay attention that we are appending these characters from the right-hand side. So it would be wrong to use left recursion. If you say the identifier is letter or character written in front of an identifier, then you would say that identifier that is correct would be, for example, 3x. Why? Because if identifier is a specific character in front of an identifier, identifier is x. That is perfectly clear. So you say, is x an identifier? Yes, it is. It is a letter. So x is an identifier. And if you put character in front of an identifier, character in front of x, then you put here 3. So 3x would be correct identifier. This is not the case. Identifier must start with a letter. So practically, this here is left recursion because you are appending on the left-hand side of identifier, and this here is right recursion. So you append on the right-hand side of identifier. So in the case of identifier, this definition and this definition are completely different things. So you cannot use this recursion, you have to use this one. Otherwise, it is not going to work. Is this clear to some extent? Is there any question? So let me conclude that this is clear.
Wait, so is recursive definition used in many languages?
Of course it is. We are going to use it. All languages are defined in this way. But this is analytic form.
Oh, sorry. Yeah, I guess I meant left recursion. Sorry.
Pardon me?
That bit at the bottom, left recursion. Is it ever that the character comes in front of the identifier?
Yes, of course, you can have this, but you have this, for example, for a string. If you say, I want to make a string. So what is string? String is a letter, or you can put character in front of string or after string. Will still remain the string. Do you agree with that? So if you have a string object, you can expand it by putting character on the left-hand side or right-hand side.
Oh, so, yes.
Yeah. In that case, you have that this definition and this definition are completely equivalent. The same is when you make an integer. You have an integer and you say an integer, unsigned integer. So 1, 2, 3, 4, for example, such number. If you append a digit on the left-hand side or right-hand side, it is correct. So sometimes left and right recursion are completely equivalent. Sometimes they are not. In the case of identifier, they are not, because the identifier must start with letter. And that's where this asymmetric property comes from. Okay?
Okay, thank you.
Okay, you're welcome. Whenever you have a question, you just unmute your microphone and say, hey man, tell me this. And I'm going to stop and answer the question. No problem with that. Feel free to communicate, because otherwise we just have no bidirectional communication. Another question. Okay. So here is definition of if statement. So you say if statement is if followed by condition in parentheses, and then after that you have block. Or you have if condition, then block, else block. So this is definition of the statement. But now we have to say what is block. So this is incomplete. I have to define what is condition, and I have to define what is block. Otherwise, I don't have definition of if statement. So here we go to define what is block. Block is a single statement. It can be if a greater than 0, put x equals 3. And the block can be a single statement, or can be a sequence of statements inside pair of braces. So a block can be left brace, and then first a statement A is 1, B is 2, C is 3. So you have here a sequence of statements inside pair of braces. So this is what block is. Of course, that's very beautiful. Just you have to define what is sequence, because now I didn't tell you what is sequence. So you say block is many statements, a sequence of statements inside inside pair of braces. So what is sequence? So you go and say, aha, sequence is a single statement, or sequence followed by a statement. So the previous question was, can you put this statement in front of this sequence? Yes or no? What do you think?
Yeah.
Bravo. Yes, of course, because you can expand sequence by putting a statement before at the beginning as a first or as a last. So it is perfectly okay. So when you define sequence as statement or a sequence followed by statement, that is okay. But if you want to define that as statement or a statement followed by a sequence, that is also okay. So this is an example where when you can have a left or right recursion any way you want, you are going to get the same thing. So we understand that what is the sequence. So how to define various objects? You start with if statement and say, if statement is condition, condition block, else another block. Now, I have to define what is block and what is condition. And when I finish that, then I have the correct definition. So block is statement or sequence, then sequence is statement or this sequence followed by statement. And then you have to say, what is statement? Well, a statement is a very tricky because it has expression, and expression is your first homework. So it is a rather big thing. So we're going to skip that for the moment, and we are going to see identifiers, examples of identifiers that are correct. So alpha is correct identifier. All these are correct identifiers. What are incorrect identifiers? Well, incorrect is 7. A plus B is incorrect because it has here plus, and we defined identifier not with plus, with only character or only with letter and digit, and this is a special character. It is addition operator, so you cannot start that. This is wrong because 700 BJ starts with 7. This is wrong because we have not put underscore as a character in our definition of letter. So letter was A, B, C, D up to X, Y, Z, but not with underscore. So that's not okay. Minus X is not correct because minus is here. This starts with digit. This here is an expression. this here is okay, but it has index. So it is not a variable, it is not an identifier. It is indexed variable. So it is a different thing. So all these are incorrect identifiers. So each syntax definition defines a class of objects, class of strings, a set of objects that are correct, while all others are incorrect. So when you say what is if statement can be if block or if block else block and nothing else. So if I have something else, this is not if statement. So this definition is a kind of filter that is telling you what is correct and what is not correct. Okay, so we go here and now make an example. And this example is something that is used on exam. So if you come to take exam, one of the questions will be in first meter, this one, for example. In Pascal, numbers can have integer or real values. In the case of reals, at least one digit must precede and follow the decimal point. Let me ask you something. Do you see me or you don't see me on this screen? The talking head, do you see that or not?
Yes.
Yes, okay, so because I can do this, let me see here. I can make, this here is rather a big slide, okay? So this head is disturbing this slide. Do you see the whole slide or it is overlapped with the head? Should we move head here like this? Oops. Or move it somewhere else, like here?
You're good, Professor. We can see.
You can see. Okay. So here is the question. In Pascal, numbers can have integer or real values. In the case of reals, at least one digit must precede and follow the decimal point. So in Pascal, for some strange reason, you cannot write 1, 2 with dot or 0.12. This is illegal. You have to have something left and right of decimal point. So real values can have an exponential part, and here are various numbers. So 1, 2, 3, minus 1, 2, 3, plus 1, 2, 3, or 123 times 10 to minus 7, or 123.45 times e to 50 times 10 to 15. So this is exponential form. You have exponential value. Oops. You have exponential value that is appended at the end. So you can have this exponential part is optional. You can put it or not put it. For example, if you have 123, there is no exponential part. But if you say 123 times 10 to 12, then you have minus 1, 2, 3, e plus 12. So we have here, obviously, what we want to have, which is an exponential number. However, if you have decimal point, you must have digit left and digit right. And if you have like 123, you can put 123.0. That is okay. But you cannot put 12 dot or dot 12. What you have in C, in Java, in C++, in Ruby, in all possible programming languages, you have that. Not in Pascal. Pascal was defined as something that has left and right of decimal point, a specific digit. So the question is, write the BNF definition of this version of number. So you have to define a number and assume that any sequence of digits can have an arbitrary size. Okay, so that's, you can say, okay, how many digits I can put? Well, we assume that all languages are always limited with some specific number of digits. So you cannot have an infinite number of them, but these recursive definitions tell you that variable name, for example, can have an infinite number of digits because recursion, if you go to recursive definition that we used here. So look at this. You go here and say identifier is letter or identifier followed by a character. So you can say, hey, wait a second, how long is that? Well, can be any number of characters that you append to another identifier. So this is defined as string that has 1 character or 2 characters or 3 or 4 or 5 or an infinite number. So we assume that always things are finite, so it is not going to go up to infinity, but the definition is given so that it can be any length. Also, if you have here exponent, no language will in normal implementation accept more than 3 digits here. So you can have 2 in most cases or 3. What's 3? Well, 308 is the maximum in double precision. So you are not going to have 999 here or 4 digits. But we assume that can be any size. So number is going to be defined as sign, followed by decimal part, followed by exponential part. So we analyze this here and say, what you have here? I have this minus. Minus is this sign. Then I have decimal part. Decimal part is 123.45. So this is decimal part. And then sign, decimal part. And then comes exponential part. So after that is exponential part that has e and has here sign, and it has another string of digits that have after that. So I can say the number is defined as sign, followed by decimal part, followed by exponential part. Nice. Now we have to define what is sign, what is decimal part, what is exponential part. For sign, we are going to say sign is plus or minus or empty. We already know that. But now we have to define first what is decimal part. Decimal part is what? Can be an unsigned number. So now I'm going to call it unsigned because unsigned is 1 or 2 or 3. So when I have to define what is unsigned number, it is a single digit or unsigned number followed by digit. And again, you can say it is also digit in front of an unsigned number. So I put here right recursion, you can put left recursion, it is going to be the same. But be careful. In this case, unsigned number is a single digit or any previously defined number followed by a digit. So this is a string of digits that can have a single digit or 2 or 3 or any number of them. Okay, so this is unsigned. But you can have also the decimal part is unsigned, dot unsigned. So if you have dot, there must be an unsigned number left, an unsigned number right of that dot. So this is decimal part, unsigned without decimal point, or unsigned dot unsigned and nothing else, and nothing else. That's the basic thing. So what is exponential part now? Exponential part can be empty. So here is 123, there is no exponent. So exponential part can be omitted. So the first thing about exponential part, it can be empty or can have letter E followed by sign, and then after that an unsigned integer. Sign is plus or minus or empty. Empty is empty. Digit is 0 through 9. Now, the last 2 comments. Can this be written upside down from digit towards number? Yes, it can. This is description for human consumption. This is not for computer to read. So you can say, I'm going to build something. Will consist of digits. Here are digits. Will use empty. Here is empty. I will need sign. Here is plus or minus or empty sign. And then here is number that I define in this way. So you can put that in any order. But the simplest possible way to go in deductive way is to go from top down. You start with the most thing, and then you go in stepwise refinement. Refine, 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 refine. Okay, so now is the time to terminate this class. So what we are going to do next time when we meet, we are going to start from here. So I'm going to put this slide on this screen, and then we'll ask, do you have some questions? And if you have questions, you start and ask questions. And then second thing that we are going to do next time, we are going to take this example of Fortran data statement. And again, BNF definition of this statement. This was also an exam. So these are typical exam questions making syntax of that. And then after that, we are going to say, today we study syntax diagrams. So we finish with this slide 20 and try to read this, try to understand. If you have questions, then ask me when I come next time. Thank you very much. That's all for today.
Thank you.
Okay.
Thank you, Professor.
Okay, thank you, thank you. Let me go to eat something.